Nothing so far. As long as tomorrow me and my teacher gonna do energies, then I'll understand it further.
Okay, electricity.
I have mastered it.
Fully.
Yes.
Okay, no problem. So let us do some few problems in energy. Then we'll see where we are. We're gonna do a few problems in mechanical energy. Okay, grade 10. Yeah, so before we even start, what is gravitational potential energy?
Gravitational potential energy.
Yes.
Gravitational potential energy is energy that an object has because of its position in the Earth's gravitational field related to some reference point.
Yes, there must be a reference point. In most of our cases, the reference point will be the ground. Okay, so what is kinetic energy?
Kinetic energy is energy that an object has as a result of its movement.
Yeah, that is true. So if an object is at rest, what is its kinetic energy?
Is it zero?
Yes. And if we have chosen the ground level to be our point of reference vertically, if an object is on the ground, what is its gravitational potential energy?
Is it 9.8?
Gravitational acceleration is 9.8. I agree with you. But the gravitational potential energy, which is measured in joules, will be 0. But you do agree? Because gravitational potential energy is given by mgh. If you remember from your notes.
Yes. Yes, I remember.
Okay. So can you please state the law of conservation of mechanical energy?
It states that the total mechanical energy in an isolated system remains constant.
That is correct. Okay. I just want to save. Okay, I just want to. Okay. I just want to open the Word document. Then we're going to continue from it. Okay, perfect. I don't want to share this one. So let me share. Yeah, are you able to see the shared screen?
Yes.
Okay, perfect. We have the following question. A boy skates along a frictionless ramp shown below. The boy starts at point X, 2 meters above the ground, at velocity 1 meters per second. The combined mass of the boy and the skate is 60. Calculate the mechanical energy of the boy and his skateboard at X. Okay, I'm gonna give you 3 minutes. We are doing the first question. Yeah, we have a new member that has joined with an unknown name. What is your name, if I may ask? We have a new member.
So it's me.
Oh, Kumisa. You okay? Uzenenye. Okay. Well, it's fine. Yeah, so we're doing 8.1. Tumisa, are you winning?
Yes, sir.
Are you done? How much did you get?
Not done yet, sir.
Okay. Tumisa, are you winning?
No, sir.
You're winning. Nungo, are you done?
No, sir.
Yes, sir.
Tumisa, how much did you get? Tumisa, how much are you getting? Tumisa. Nungo, how much did you get?
1,206 joules.
1,000?
206 joules.
Okay, 206. 206 joules. Tumisa, how much did you get?
Say, I said 1,206.
Okay. Tumisa? Okay.
Sir, I'm not winning.
Oh, you didn't get it? Okay, no, it's fine. Let's do it together. The mechanical energy, if you want to find the mechanical energy, you have to look for a point which has all the parameters you need to calculate the potential energy and the kinetic energy, meaning you have to find a point with a known velocity and a known height. First step, find a point with a known velocity and a known height. This point, they said the boys start at point X, 2 meters above the ground. So we know the height, that's number one. Number two, if you know the velocity, find a point with a known velocity and a known height. So at X, we know the velocity is 1. So that's where you're going to calculate your mechanical energy. That's the first step. So mechanical energy is given by 1/2 mv squared plus mgh. This is 1/2 into the mass of the object. In total, we have been told that it is 60 kg. So it is going to be 1/2 times 60 kg times velocity, which is 1 squared plus 60 times 9,8, which is our g, times the height is 2. So if you use your calculator, let me see what I'm gonna get. If I use my calculator, I'm gonna get, okay, let me charge my computer so long, times 60 times 1 plus 60 times 9,8 times 2. I'm getting 1,206, which is correct. Okay, 8.2. Determine the speed of the boy and his skateboard at point Y. 2 minutes. So the answer that I got is 1206. 1206. 1206. So which is correct? Joules. That is the total mechanical energy. Now determine the speed of the boy at his skateboard at point Y. Eight point two. Determine the speed of the boy and his skateboard at point Y. Kumisa, are you winning? No, are you done?
Yes, sir.
How much did you get? No.
3.29 meters per second.
Kumisa, how much did you get?
Results not here.
Okay, no problem. Let's see. You got 3.92 meters per second. Okay. Okay, this is Nogo's answer. So
3.29.
3.29. 3.29. Okay, let's see. Mechanical energy. If mechanical energy is conserved, the mechanical energy at X and the mechanical energy at Y and Z will be the same. Therefore, if Emech at X is equals to 1206, it will be equals to 1/2 mv squared plus mgh at point Y. At point Y. So 1206 will be 1/2 into 60 times v squared plus 60 times 9.8 times the height. Yeah, I think Kumisa is back. Kumisa, you back? How much did you get? Okay, 1206 is equals to 30 v squared plus 60 times 9.8 times 1.5. 60 times 9.8 times 1.5 to be 882. So if I take 882 to the other side, I am going to get 1206 minus 882, which is 324. It's equals to 30 v squared. If I divide by 30, 324 divided by 30, it gave me 10.6. So v squared is equals to 10.8. So v is equals to the square root of 10.6, 10.8, which is 10.8, which is 3.29 meters per second. Okay, that's perfect. Okay, they are saying 8.3, use relevant calculations to show that the skateboard will not be able to reach point Z. 2 minutes. 2 minutes.
Could you please go up?
Okay, sorry. Okay. There's so many ways to prove. There's so many ways. So I just want to see how you will interpret your way. So many ways. There's so many ways. We are now doing 8.3. We want to prove we want to prove 8.3. There's so many ways to prove. Okay, the boy started at point X. Point X is 2 meters above the ground. Point X is 2 meters above the ground. Okay. So we have X, Y, Z. Misa, are you winning?
Yes.
Okay, are you done? Okay, Nungo, are you also done?
Yes, sir.
Okay. Okay, Nungo, can you tell me step by step, what did you do to prove?
So I'm not really sure about what I did.
Okay.
So I decided to ca- um, decided to calculate um the height.
Okay. You have calculated the height. 8.3 using which formula? Just tell me what I should write.
1/2 mg squared plus mgh equals to 1/2 mv squared plus mgh.
Okay. And then
1/2 multiplied by 6
okay,
multiplied by 1 squared
1 squared
plus 60 multiplied by 9.8 times h.
times how much?
H
8.
height times
Height.
height
Okay.
equals to 1,206
1,206. Okay. Okay.
then
This will be
580.
30 mostly.
Yes,
Okay. And then
30 plus 588 h.
okay, 30 plus that.
30 plus 588 h.
30 plus 588
H
h is equals to
equals to
1,206. Okay. Then you take 30 to the other side.
yes.
588h is equals to would be 11706. Am I right? No. No. 11
76.
is it? Let me check. 1206 minus 30. 1176. Yeah, you're right. 1176. And then we divide by 588. 588. So your h, how much did you get?
2 meters.
H equals 2 meters. Oh, okay. So you are saying that your object won't pass 2 meters.
Yes, sir.
And that is correct.
Oh,
Yes, there's so many ways. It won't pass 2 meters. I mean, if you go back to your diagram, you will see that at X, your object was at rest, right?
yes, sir.
And it was at 2 meters. It means if it goes down and when it goes up, it must reach 2 meters. And at that point, your velocity must be 0. It must be at the turning point. That's another way of proving. Another way of proving, you can calculate the potential energy at that point and see how much you're gonna get. If it's more than the mechanical energy, then it won't reach. Your potential energy, your EP, it will be mgh, which is 60 times 9.8 times height of 3. How much do you get?
1,764.
1,764. Okay. 1206, which is our mechanical energy, is less than 1764. Then you have proven. That's another way of proving. Another way of proving is to calculate the velocity at that point. The total mechanical energy is 1206. At that point, if you're calculating the velocity, you're going to have 1 over 2 mv squared plus mgh at that point. So you're going to have 1206 equals to 1 over 2 times 60 times velocity. This is what we are calculating. Plus 60 times 9,8 times the height of 3. So 60 times 9,8 times 3, 60 times 9,8 times 3, it gave me 1764. And this gave me 30 V squared. And here I have 1206. So if I take 1764 to the other side, what am I going to be having? 1206 minus, because this will be a minus 1764. How much are you getting? Okay, so if I divide both sides by 30, I will have V squared is equals to 558 divided by 30. I'm getting 18.6. I'm getting minus 18,6. So, sorry, V is given by the square root plus or minus the square root of 8 minus 18,6. Okay, take your calculator and press the square root of minus 18,6. If you get the answer, if you get a specific numeric answer, then I owe you a drink. If you get a numeric answer, I'll get you a drink. You can use your calculator. We are trying to prove. Okay, Kumisa, how much are you getting?
Math error.
You're getting error. No, how much are you getting?
Math error.
Error. So this is undefined. Meaning you won't reach. There's no such. You won't be able to reach. That's another way. There's so many ways. So one last example, which I think it's gonna be very critical in your exam, is this one. Okay, let me check it. I want us to do it again. This one. This will be the last. It's a bit. Okay. Just tell me if you're able to see. Okay, we have a small ball with a mass of 900 grams that rolls down from rest along a frictionless surface, AB. Point B is 7 meters below the starting point. The ball continues its motion from B to C, where it experiences some frictional force and finally comes to stop after covering a distance of 10 meters. The motion of the ball is shown in the diagram below. Okay, so this is point A, and this is 7 meters. And this is 10 meters from here to there. And the ball is 900 grams. Point A, point B, and point C. Calculate the gravitational potential energy of the ball at a height of 7 meters above the lowest point. They are giving you a very nice clue of calculating the mechanical energy, but that's what you're gonna do. do later. But they said calculate the gravitational potential energy of the ball at height 7 meters above the lowest point. 2 minutes. This one is very easy. Okay. Kumisa, are you winning?
Yes, sir.
Are you done?
Yes, sir.
Okay, how much did you get?
61.74.
0,
4.
60. Okay. Nungo, how much did you get?
61.74.
Okay, 61.74. 61.74. That is correct, Jules. That is correct. It's just MGH and that's it. Now state the principle of conservation of mechanical energy. Kumisa. The principle of conservation of mechanical energy.
Energy cannot be created or destroyed. It can only be changed from one form into another.
Now that is the principle of energy conservation in general. You're gonna get a partial mark. You're gonna get 1 mark. I want the one which is specific for mechanical energy. In an isolated system, mechanical energy is conserved. That's what you need to say. That's all. Mechanical energy is conserved. Okay, 7.3. Is mechanical energy conserved from A to C? No. Is it conserved from A to C?
I'm not sure, sir.
Okay, Kumisa, is it conserved?
I'm not sure as well.
Okay, from A to B, mechanical energy was conserved. Why do I say so? Because the object rolled down along the frictionless surface. The frictionless surface is only between point A and B. So where the surface is frictionless, mechanical energy is conserved because energy is not lost due to friction between those 2 points. Are we all together?
Yes, sir.
So whenever they start mentioning that there was friction, that's when you know that there's energy lost due to friction. There's energy that's going to be lost. Whenever there's friction, your object will decelerate and stop because the friction will be fighting against the motion. That means it will be consuming the mechanical energy, and the mechanical energy won't be conserved. Okay, that's fine. So the mechanical energy is not conserved from A to C because between B and C, there was friction. Not conserved. Fine. 7.4. Calculate the magnitude of average acceleration experienced by the ball from B to C. Because the ball started decelerating from B to C. Now they want us to calculate the magnitude of average acceleration experienced by the ball from B to C. Okay, this is not conserved. Okay, this is where we are. I want you to see everything. Okay. Okay, perfect. Calculate the magnitude of acceleration experienced by the ball from B to C. That is the question I was interested on. 6 marks. You might get this exact question in the exam. I have that feeling. We are doing the last question. We are actually preparing an exam for the grade 10. We might write it next week. Next week, maybe Saturday or Thursday. I'm gonna share a link if you want to write the exam. So whoever gets position 1, 2, or 3 will be awarded, and the award will be sent to your principal. Will send the award to the principal. If you want to participate, there's going to be quite a number of schools. If you want to participate in the pre-final exam, and we will share the link. So the exam will be online. It will be online. It will be a multiple choice. You're going to write the exam at the comfort of your home. You're going to write the exam at home. You're going to write the exam at home. If you want to participate, we're going to have a pre-exam, pre-final exam competition. If you win the prize, there's few people who have sponsored the competition, so we will award you with money. The money will come to you, but the prize will go to your principal. The trophies will go to your principal. The trophies will go to your principal. Okay. Nungo, are you winning?
Not really, sir.
Is it difficult?
Yes, it's complicated.
Okay, I'm glad. I'm glad it is complicated. Because there's a possibility that you're gonna get a question like this in the exam. Kumisa, are you winning?
No, sir.
Okay, now let us do the question together. Let us do the question together. Calculate the magnitude of average acceleration experienced by the ball from B to C. Okay, we were told that at point A, the ball was at rest, meaning the velocity was, how much was the velocity at point A? No. 0, perfect. Do you agree that the potential energy equals the mechanical energy at that point? Okay, so we do know the total mechanical energy. Okay, using the total mechanical energy, we have two scenarios. So whenever you do problems in motion, you must divide your problems into scenarios. There's the first scenario from A to B. So our initial velocity was 0, but we want to calculate the final velocity on the first scenario. And the final velocity of the first scenario will be the initial velocity of the second scenario. Okay, that's fine. Between A and B, that is the first scenario. between A and B, we know that mechanical energy was conserved. EMAC was conserved. Nungo, do you agree with that?
Yes, sir.
Okay, so if it is conserved, we are allowed to use the equation of conservation of mechanical energy. Okay, give me a minute, let's see. Okay, so that equation, it is, we know that 60, which is the total, 61,74, which is the total EMAC, is equals to 1/2 mv squared, the velocity at B, plus mgh height at B. 61,74 is equals to 1/2 times the mass is 0,9 times velocity squared plus 0,9 times 0 times times 9,8 times 0. So this will be 0. So 61,74 is equals to 0,45 v squared. So if we divide by 0,45, 61 divided by 0,45, how much are you getting now?
Um, 137,2.
137,2 is equals to v squared. And the square root of 137?
11,71.
11,71. Now, this is the velocity final for the initial scenario. Now, we are going to the second scenario. In the second scenario, which is from B to C, our initial velocity will be 11,71. Okay, we have a scenario between B and C. Okay, the initial velocity was 11,71. That is V initial. And the change in displacement, we need to choose the reference point because we are dealing with vectors. So if I choose this as my reference point, because they have said a lot about displacement, at point B, if I have chosen B to point B to be my reference point, I am going to have initial displacement as 0. And what will be the displacement at C? No. Let me go up. What will be the displacement at C?
Is it going to be 10 centimeters?
It is going to be 10 meters. 10 meters, you're right. 10 meters. And what will be the final velocity of my scenario from B to C, to Misa? What will be my final velocity?
11,71.
Nungo, do you agree with that?
Is it 0?
It is, okay, let's go back to the scenario. They said that the ball continues its motion from B to C, where it experiences some frictional force and finally come to stop after covering 10 meters. Kumisa, what is the final velocity?
Zero.
It is 0 because it came to stop. Okay, perfect. No problem. So this is what I want to do. I want to copy and paste. Give me a few seconds. Okay, I want to copy and paste. Okay, let me use. Okay, this one will work. Okay. So that is the information we have. Okay. We have the following equations of motion. Okay. Which equation do you want to select? Because you have to select one equation of motion in order for us to calculate acceleration. Because we were asked to calculate the average acceleration. Which equation were you gonna pick? Nungu. And by the way, U stands for initial velocity. Don't be confused.
Equation number 4.
Equation number 4. Kumisa, do you agree with that? Okay. So our final velocity is 0. Our initial velocity is 11,7. Okay, on our frame of reference, we have chosen the direction of right to be positive. Just bear in mind. Okay, so your final velocity is 0. Your initial velocity is 11,7 squared, which is positive, plus 2 times acceleration, and the displacement is also in the positive direction, if you check. And Kumisa, how much is the displacement? Or the change in displacement?
0.
Anungo, do you agree with 0? The change in displacement?
It is 10.
It is 10. Kumisa, remember, our point of reference, we started at B. And your object moved from B to C. The displacement was 10 meters, you can see. Okay, then that's fine. Now, if I take 11,7 squared, how much are you getting, Nuru? Eleven comma 7.
136,89.
Okay, 0 is equals to 136,79. Okay, plus 28. If I take 136 to the other side, I am going to get minus 136,79 is equals to 20 times acceleration. If I divide by 20 to get rid of 20, use your calculator and go 136,79 divided by 20.
6,84.
6,84, which is negative.
Yes, sir. Yes, negative 6,84.
So your acceleration is negative 6,84. Nungo, why is the acceleration negative?
Because we are decelerating.
Yes, that is perfect. The object is decelerating. It is accelerating in the opposite direction. Okay. Nungo, do you have any further questions?
No, sir.
Tumisa? Tumisa? Okay, I think. Okay. So I just want you guys to be cautious of the fact that in your exam they can combine mechanical energy and the equations of motion when they want to. So if they do, please do not panic. Just stick to the principles. Make sure that you divide each scenarios. For instance, I have divided scenario A to B and scenario B to C. So the initial velocity, the final velocity of the first scenario was my initial velocity of the last scenario. And in this case, you must always bear in mind of the terms like frictionless surface. So whenever there's a frictionless surface, just know that mechanical energy is conserved. The other thing is keywords like starting from rest. If your object is starting from rest, your velocity will be 0 at that point. So whenever there's friction, mechanical energy won't be conserved. So I will try to put a question like that in the pre-final exam just to see how prepared you guys will be. So if there's no question, thank you so much for being part of this lesson. And I will see you guys again on Thursday. So if there's yes.
Can I screenshot the worksheet?
Oh, okay, no problem. You want to screenshot the answer?
No, the worksheet.
Okay. Is it fine?
Yes.
Okay.
Done.
Okay, perfect. So I will see you guys on Thursday. So I'll try to also compile difficult questions that I think might be in the exam. So on Thursday, it's going to be 6 o'clock. Same time, 6 o'clock. Thursday, 6 o'clock. And for those who want to participate in the pre-final exam, I will share the link. I will share the link. Okay, I'll see you on Thursday. Okay, now for those who are on TikTok, I have already shared the link, but I'm gonna reshare the link. I'm gonna reshare the link for those who want to participate in the pre-final exam. In the pre-final, so it's sort of like a preparatory exam. So I'm gonna share the link to the WhatsApp group. And the date has not been set yet, but I'm aiming at us writing it next week, maybe Thursday or Saturday, before you start with your exams, because I've been told that you are starting your exams in 2 weeks' time. So I will try to facilitate everything quickly. So there is the link. I've shared the link for those who want to join the exam. So I've shared the link. I've shared the link on the chat. For those who are on TikTok, I have shared the link. I have just shared the link. So if you want to participate, if you think you can beat everyone in math, in physical science, I have shared the link. We are going to write a pre-final exam, hopefully next week. Next week, hopefully Saturday or Thursday. If you think you're that good, if you take position 1, 2, or 3, you are going to get the prizes. The trophies will be sent to your principal, and the money will be sent straight to your account. The money will be sent straight to your account. I have shared the link. Oh yeah, someone is asking when will I do the maths live for grade 10. Unfortunately, the person who is teaching maths usually don't do the lives, but I will try to do the lives on Saturday. I will try to do the maths lives on Saturday because we are trying by all means to squeeze all the revisions. We're gonna do more revisions. So we're gonna do revisions Thursday, and I'll try to do it on Saturday. If I get more time, I'll also do it on Sunday. Since we are writing, we're gonna do more revisions. Okay, I've shared. I have shared the link. If you want to join, if you want to participate, the exam will be fully online. You're gonna be writing either on your phone or your laptop. It's gonna be a multiple choice question. You're gonna write in the evening around 6 o'clock. Okay, someone is asking where did I share the link? I'm gonna reshare the link, no problem. Can you see the link? Please check the link. There is the link. There is the link. And also, if you're struggling to join the link, you can even inbox me. It's fine. You can even inbox me. You can inbox me, or you can try to follow the link, because I can see it might be tough for others to copy this link. If you can't copy the link, you can inbox me or on TikTok. Then I will add you to the group. You can inbox me, I will add you to the group. If you think you're that good in physics, we are going to have a competition next week. No problem. We're gonna do functions and Euclidean geometry next on Saturdays. We're gonna do Euclidean geometry on Saturday. So I will remind you on Thursday as well, if you will join. So I will see you guys on Thursday, since I have a grade 9 class to run at the moment. Okay, cheers.